this one. Recording in progress. And I would offer myself to take the notes today and somebody else take over the lead, or some of you to just do the notes. Second. Okay. Then anyone wants to share the discussion from the last meeting, which has been US Asia, I think, 2 weeks ago. Was it?
Should be US Euro.
Let me check. Yeah, US Europe. Sorry. Yes. Yeah. So the discussion went on what we picked up about the target platforms, target operating systems, and so on and so forth. And one of the colleagues prepared a Excel sheet on and pushed it to GitHub, which I'm trying to find out. So I think the discussion went pretty much the way we did it 4 weeks ago in the EU Asia. And but we had some offsite discussions, to be honest, about target platforms again. And this is one question I would like to raise today. And because honestly, we were looking at things and looking at 32-bit Linux platforms and so on. And if you start a project today, there isn't much of that. And if we really should consider brownfield devices, this is like the baseline question we raised internally when we discussed between the meetings. So how is your stance on that? Because to be honest, I don't see a use case where we would take an existing device, which is, I don't know, 5 years old or older, and we would put a WebAssembly runtime in it, to be fair. So I only would consider platforms from now on to the future. Does some of you have a use case where you would enable old devices? Sorry.
Yeah. Oh, sorry. Go ahead.
Go ahead, Martin.
Okay, thanks. Now, I just want to say that we do have this use case. We are porting WebAssembly to old devices, not even 5 years old, sometimes even older. So definitely that is the case.
Okay.
Yeah, I agree with Martin. We also have some devices that are 9 or 10 years old inside our company. However, the question is it really necessary to make WAMA run on those old devices from our point of view? I have seen the Excel sheet. I do not know where it is on GitHub, but Toby Aldram sent it, Dominic, as you might know.
Yeah.
So to me, it's more about the question about the feature set that a specific device offers, be it RAM, ROM, the MPU, MMU, etc. I think this is quite important to distinguish between. Also in terms of performance, right? When we're looking for new proposals, and new proposals have an impact on performance or imply more cache pressure for example, then this is very important to us, as you might know. So the question about is it a new or an old processor, to us, I guess, is not that important compared to the processor feature it offers.
Yeah.
But I totally understand you, Marcin, because you have the use case to make it available on really old smart TVs and then set-top boxes and
Okay.
whatsoever. So I get the point.
Yeah. So I just posted the link to the branch, and it's in a pull request. So with the updated target platform file. Is the question why I'm asking this? So we were discussing about MPU, yes or no. So I still personally feel I would personally feel it would be better to have the MPU as an optional feature. But to be fair, if you consider like Cortex M series as of today, they do have an MPU in. It might not be activated, but everything onwards, everything, you know, don't speak in absolutes, but more or less everything onwards has an MPU. So if we somehow agree that we do not consider brownfield, then we could cut this discussion short and say, okay, there's an MPU. Period. But Marcin, if it's not the case for you, so for us we would be totally okay with it. But if it's the case for you, then let's say I would say the definition of the lower barrier then lays more on your side. More or
No,
less
I
like,
think all the platforms that we have, they have
Yeah.
MPU, so it's not a problem.
okay, yeah. So that is what I mean. It's not just about the MPU. We were just looking at, okay, if you look at memory and you just open the, I don't know, data sheets of ST as of today, you can look at this as it is today. But because for us, the like looking back in the past use case is not so important, I'd say. But if it's important for you, then we include it. So this is why I'm raising the question. So okay, cool.
So maybe just a question.
Please.
This list of target platforms. What is the exact goal of this list?
To my
Is this-
understanding, sorry.
Yeah, go ahead.
To my understanding, it is about to define a kind of references, such that the community can maybe hop on and put their proposals when testing, also for this kind of platforms, because there were also ongoing discussions, as I said, about performance, about processor features, what is the behavior with MMU, with MPU, with sandboxing, no sandboxing, etc., etc., etc. Floating point calculations, SIMD, and so on and so forth. And the question was, okay, what is good enough for you?
Yeah.
And this is kind of difficult to say, because normally you don't have absolute numbers, but relationships between native execution and AOT execution, for example. And in case you need a deterministic responsiveness, then the question is, how much worse does it get compared to native execution, for example? And you will find differences, whether you have an MMU, whether you have an MPU. You will find differences on the cache sizes, level 1, level 2, level 3 caches, etc., etc. And these kind of platforms, to my understanding, are about to define reference platforms to do the tests and maybe also do performance benchmarks, etc. And so we should strive for a we will not find the perfect fit, but a local optimum, let's say.
Yeah. I wonder if there's some way we can work with like multiple tiers of support. For example, if we see that it's a certain platform that is almost shared with everybody. For example, having an MPU or something, or like certain RISC-V boards that we know are very are used by most members of the SIG, then we see this like as a tier 1 platform, like an A-tier platform, where the idea is that every single thing we build, like for example the I2C interfaces that we're building, we assume that it should work on those platforms, and then we can have like tiers where the support is optional, but we know that still some people are still using these platforms, and then we get into the territory of like Marcin, what he is working on, where it's a platform that we know it's not super common, it's not something that a lot of people use, but it's still something that some people use. And then we could say like it's okay for a proposal to go to the next phase, even if it doesn't support these optional platforms.
I think it's, well, yeah, if we have those tiers and we say that only tier 1 needs to be supported when it comes to some new proposals, then I wonder if there is much sense even maintaining the tier 2 list if it's not even taken into account during the moving to different phases of the proposal. And that might just complicate things, because then within, let's say, tier 2, you might have devices that support subset of features, but there will be different subsets of features. And that might even complicate things even further. So within tier 2, we might have like different groups of devices. So I'm not sure if it's worth complicating those things. Maybe we just should say, if, maybe we should just accept that we just select a list of devices that we say are supported, and the other ones, maybe not.
Yeah.
Best effort.
I think it can be useful to have an idea of which devices are actually still being used, because there's way more unsupported devices than devices that are actually being used. One of the uses for this second tier is to know like, okay, these devices are still being used, but we don't have to block proposals if they don't necessarily work on these devices. Or the same with tests, for example. If a device is not actively being sold anymore, it will be very difficult to put it in test beds, put it in CI/CD, but we still know that some people are still using it.
No, yeah, I understand that. It's just, I think it might just generate unnecessary noise in the discussions, because eventually we will agree that those are tier 2 devices, so they, the proposals don't have to be compatible with them. And it's just, I'm not so sure what is the value other than just knowing they are devices like that.
So I think in general, so the discussions we had and we are having, and the lists we are creating here is really to, let's say, just create somehow a boundary or scope for the things we're doing. So let's take the MPU example because it's a low hanging fruit and it's easy to understand. So we if we decide to go forwards and rely on an MPU, we could just look at the how this would affect the hardware landscape we have. And if a lot of our hardware would not support MPUs, then maybe the solution we are thinking of is not the right one. And to give it a little bit of context and looking a little bit at the memory, so this is the memory we are looking at, and this was the discussion. And so I don't know if the solution which we are proposing in the end adds an additional memory of 120 something kilobytes on top, is this still in range for our target devices or not? And so just get a, let's say, an idea about that. For really implementing our demonstration, we need to be a little bit more picky and say, okay, we take this platform as a representative for this kind of hardware and that platform as a representative, because I think we cannot achieve to have a implementation for, I don't know, 20 or 30 hardware platforms done easily. Maybe we can if we look at things like Sapphire, but if we go to less generalized interfaces, then it will be a huge maintenance effort to have a lot of platforms in scope, I think. Just my feeling. Yeah.
I'm not sure about the purpose of this list. So is the purpose of the list that if a proposal does not support the whole list, then the proposal must be rejected? Or is the list about target platforms that we would like to see supported by a proposal? So is it a must-have or is it a should-have?
So I see it more as a, again, I see it more as like defining the limits. So looking here, so this would be like the lower limit would be some Cortex M0 core, which really is super restricted on memory and processing power, and then this I would more see like the, let's say, upper boundary for really deeply embedded devices. I mean, there's no upper boundary, but as of today, I would see like this is the one of the more capable stuff. So there's this H series, the high performance series at ST, so which is a little bit more performant. But if we look at deeply constrained or deeply embedded devices, I would say something between 50 and 200 megahertz, and something between, I don't know, this is a little bit too low. I think we agreed on like
I also agree
250K. Yeah. So it's more limits. So it's just a proposal for the limits, and these could be representatives of these limits.
Okay.
And if we now go to, okay, we want to, I don't know, we want to extend it towards a GPU interface, then it might not address all the interfaces. Martin, please.
Yeah, so similar question to Thomas. Is this for WebAssembly core language, or is that for WASI? Because if this is for WASI, I think it is a whole different story. If it is for core language, then I think it sort of makes sense to me.
Yeah, very good question. I'm also not sure of the scope as of now. Core WASM, totally agree. And also totally agree to Dominic about the limits, right? So if it's working on more sophisticated platforms, just fine, right? And if we're talking about resource constrained devices, this is what we think about. So this is what the list is for. Marcin, if you're talking about WASI, yes, I agree in parts. Because when I look at the let's say Cortex A series with the 1.8 gigahertz, I would definitely want to see WASI running on those platforms, right? Not only core. If we're talking about a Cortex M33, yeah, because then the question is which persona is working on it, and if the persona is an in-company persona like in Amazon, in Siemens, in wherever, then I think yes, because you will find ways to, or you have to find ways to use core WASM and maybe link something to it to make it usable without using WASI at all, maybe. But if you want to expose the possibility that another customer, so from our perspective, our customers want to use some open source library, then yes, you cannot put the burden to those people to fiddle around with the tooling. They need to use WASI.
No,
There
I
also
thought,
these kind of processors are in place.
Mm.
Maybe not in M33, but yeah, Cortex A7 could be, A53 could be, and their WASI kicks in.
no, I understand that. Well, just my concern is that if we define this list and that list contains really low-end devices, and we say that this is a must-have for all the WASI proposals, that might be a bit too high bar for some of the proposals at least. And sometimes that might not even make sense to implement some of the proposals on those low-end devices because there's not even a use case for that. So I guess what I'm saying is that it's good to have that list, but I don't know if we should define it as a hard requirement for all WASI proposals. Probably it should be discussed case by case.
Yeah.
And when it comes to core WASM, then maybe we should be a bit more strict. But even that, I think just giving a numbers like, oh, the CPU needs to be at least, the whatever proposal needs to run on the CPU with I don't know, 50 megahertz. I think it will. Any core WASM proposal will. It will just be slow, possibly. So because you always have an option to implement things in a software space, not even touching the hardware. And so I just wonder how should we define the thresholds, because just saying that it needs to run on 50 megahertz CPU, yeah, I think it's fine. All of the proposals from WebAssembly probably will run on the CPU. They'll be just super slow, some of them. So I think it's important to establish how do we evaluate if the proposal is suitable for the CPU or not.
I would suggest to have a to add to the Excel sheet at least one column stating, okay, WASI proposal should run on this, and then you can specify that for the very low end device. Okay, nice to have if it runs, but if not, understandable. And on the more performant platforms, you can say no, it's really a must, right?
Yeah, but even there, I don't know if we need to like break down the WASI proposal, because most of it I would really like to see run on the deeply embedded devices and looking at portability of stuff and I think even the WebAssembly runtime on this looking at actors and sensors only makes sense if you can act and sense, so like access the physical world outside.
Yeah,
and then if I want to,
right, if you have no wireless LAN or no Ethernet port, then yeah, you just can't do it.
But let's say we do I don't know, a proposal for sockets. Might still be suitable if you have socket support on your embedded devices, but maybe not all have them. So then you're out of it. And even if you go to higher layers, let's say, I don't know, somewhere down the road there's a WASI proposal for gRPC, which I think doesn't make sense to look at Cortex devices then. So a little bit divide it down and say, okay, this makes sense, this doesn't make sense.
Yeah, but it's not only the hardware platform; it's also the operating system, right?
Yeah, sure. Then it becomes a combination of both.
Especially for WASI, this is very crucial, as we found out.
Yeah. I mean, if we look at WASI and I mentioned it, if we go for Cepher, which has a pretty well-defined API towards the hardware, and then a WASI implementation can be done. if you go to FreeRTOS where it's like there's no defined API, then maybe we can provide an example implementation for 1 or 2 device families, but it will not run on any other device. So, yeah. So these are the things. But for the VASI, I think it's hard to have like a global column to say it works not. So we really need to drill down, and some of it will work, some of it will not work, I think. Yeah.
Regarding the performance, Marcin, right now I don't think that it would be a good idea to give kind of thresholds or limits that must be fulfilled. I think that highly correlates to the proposal itself and not necessarily just on the platform where it gets executed. So if you find out for a WASI proposal that it hits the performance very drastically on a huge variety of platforms and processors, then I think that not only in the embedded SIG, but also just in general, design decisions should be discussed for specific proposals.
Yeah, but so that's the thing. It's quite subjective to say that the performance impact is significant or not, right? So
but you, if you do it by numbers, right? So you measure it, and you just say, okay, this proposal is a new implementation version of this and that, and now the performance drops by 20% compared to the other one. Then the question is, okay, why is this the case, and is this acceptable?
So you already put the threshold. You said 20%, right?
Yes. Others have 50%, others have 70%, another one has 5%. But this needs to be discussed in the community, I guess. I would not dare to set a fixed threshold that must be fulfilled for everyone. I don't think that this works.
So one of the things I just wanted to clarify is Marcin's question about, is this about WebAssembly, core WebAssembly, or about the system interface? And I might be wrong in this, but the way I interpret it is that this is specifically about the system interface. This doesn't mean that all system interfaces need to run on on all these platforms, but adding a platform in the list and then saying, but we're actually only going to use core WebAssembly on this platform. I don't think that's part of this specific special interest group. I think that's more to do in the WebAssembly community group, for example.
Sorry, I didn't get your question right, I think. Sorry.
I think that part of this discussion also started because when we started creating the I2C proposal, we had to have portability criteria. And then we basically asked everyone, like, what should our portability criteria be? And then we settled on the 3 platforms that I linked to in the I2C proposal. Like, I think if it would be useful if we could have like 3 platforms or something to add to portability criteria with following, even if our list is much longer.
Yes.
I think I like this. Yeah, I like this idea. maybe that should be part of one of the phases of the proposal, to look at the list that we're defining as part of this group and select a subset. If the subset is all of the devices, fair enough, and agree with the community on that subset. Yeah, I like it.
Yeah, and this is where what I see, and I think Stephen wrote it in the chat as well, that like, and this is how I feel. So we are now in the phase of defining the superset, and then from that we can pick the subset. So this is how I feel. So I'm not yet saying, okay, this is our target platform, and so just as like, just create a world, just a superset. Yeah, I don't know if we, I mean, we discussed it now in this round and the round before in the Asia US. So I feel that we are coming close to have a definition of our field, which I'm sure we will change a couple of times in the upcoming month. But okay. So are there any more questions to this Excel list, or is it somewhere understood? So the link is shared, and so I think in the link I shared, there's also a markdown file where the where this defined, let's say, the embedded SIG target platforms, it's called, and it has something in there, some points missing. I don't know if we want to spend the second half of this meeting to look if we can make some progress here, or has anybody some other proposal?
This spreadsheet only has ARM architecture. I remember we proposed a few other architectures like ESP and was ARC. Yeah, so we are working on some ARC-based platform. ARC from Synopsys. Yeah. Also x86.
Yeah, I agree, because we also are working on x86, of course. I think the assumption is that if it works on those low-level devices, it will also work on high-level devices, also on x86. But I'm not sure about that. I wasn't in the discussion, so I do not know why they are not listed yet. But maybe x86 are not treated to be somehow super constrained devices.
I think so. Let me quickly share the. So I would just share the other document, maybe. So maybe this makes it then easier. I don't know how familiar you're with this one. Let me quickly find the share button. I need to.
Yeah, we also talked about RISC-V in the markdown file. You can see it listed.
Yes. So I think the Excel is just some other example, and that's something to extend from here on, and I think this is the let me file, and here we have Extensor, RISC-V, ARM 32 and 46-bit, and x86, where, to be fully fair, I would rather have a subdivision in the ARM class, I think, which we did before. So let's take the time to work on this document here.
I'm not sure how you see the ARC, because we really don't see a lot of ARC-based chips, but we will be working on that.
Mm-hmm. Mm-hmm.
So do you think the ARC cores need to be especially listed here?
The ARC processors, Xin, do you have a lot of questions about it, or a great pull in the community?
This is internal project. So because they is some IP core, so so we're not sure, because we have to support that, but we really don't see a lot of requests from the community and publicly.
Mm-hmm.
And so in our product, the ARC process with DSP accelerators. So actually, we are also working on how to utilize those accelerators for vision audio acceleration, and like you can compile some code into WASM SMD, and further compile those SMD WASM opcode into DSP instructions.
Mm-hmm.
But those yeah, maybe just really I'm not sure how popular ARC is.
Yeah, so I'm not aware of it broadly, but I might miss it. So. Mm-hmm. Is it worthwhile to file a question in Zulip chat in the SIG-Embedded?
Maybe, yeah.
Yeah, that's maybe you can just list the name here and put a question mark behind, and we can have a more offline discussion.
You mean in this document here? Like here you mean, or really at the instruction set level?
Yeah, I'm asking my colleague what the instruction is for ARC. Hadrian, do you have an idea?
Okay, there's a raised hand, I think. I think you can just speak. No.
Yeah, as well, related to that discussion, I've opened a PR to this repository maybe a week ago about adding MIPS to the instruction set. I'm not sure though, how popular it is. We do have devices based on MIPS, not many, but there are. And I'm not sure if you'll be happy to include it, just a MIPS 32-bit. I know Hammer already supports it, but yeah, I'm not sure if this is popular among the other companies.
It has been.
Okay.
So I think, yeah, so for me, it brings me back to our initial discussion that for us, it's more like looking forward. And if I look forward, I don't see MIPS. But again, so it's not just us. And if it's a valid use case for you, but as I understood it, it's like even for you, it's an edge use case. You only see rarely or.
It's definitely a small subset of all the devices that we support. Yeah. That is why I wasn't sure whether we should include it or not. At the same time, I think it's not a one-way decision. I presume we're going to revisit this document in a year or so and maybe add more instruction sets, remove instruction sets that are no longer needed. So,
I mean, so maybe what we could do in this document here, and please correct me if it's a bad idea. Maybe really we can here introduce what you call tiers, I think, and say we have second tier, first tier devices, and because this document we will later use for a decision. So we need to make a decision on a particular technology or a particular thing to use, and this relies on whatever, and at least when in our decision space, we should make sure that our tier 1 devices will support it. And if we then exclude a tier 2 device, then we can make a decision or not on that. I don't have a good example for that, so I'm always coming back to this MPU example, but maybe there's something else in the future. I don't know. And so long story short, would it make sense to put the tiers in the ISA part as well here? Yeah. It will be a pull request in the end, so it can be rejected anyways. Huh?
Well, it should be reflected that we are talking about having tiers or not. Somehow. So somehow it should be documented.
Yeah.
And we had the discussion whether it's it makes things too complicated.
Yeah.
To maybe have it simple, then of course this is just platforms that we want to see, not a definite list that must be supported.
Yeah. So this is what I'm targeting a little bit at least at the instruction set. We look a little bit towards must be supported and should be supported somehow to differentiate.
Yeah.
So if let's say MIPS has, I don't know, MIPS does not support XY, but XY is needed and every other platform does it, then we could take the decision, okay, then it will not work for MIPS. So a particular implementation of a particular system interface will not work for MIPS. Then this is what I mean with like second or must support and should support or something like this. Because my fear actually, but maybe it's unfounded, is that if we make the list of instruction sets too long, then we will not, we cannot find solutions anymore because there's so many constraints on each and every decision. Then, unless we see that instruction sets are all equal or similar, then it's not easy.
Yeah.
I mean, here we have a should be supported in the headline as well. So we already have the should word in.
Yeah, to me, must, if you just look at the amount of selling numbers of processors, so from this point of view, I think ARM and x86 are just must-haves. Extensor, I'm not sure, to be honest. And RISC-V, I'm also not sure if it's still on the verge of coming or if it's stalling. I'm not sure about that.
I think it's a very regional. So depending on which region you are in when you ask this question about RISC-V.
Yeah, but we are now Europe and Asia in this meeting. So yeah, Asia, of course, RISC-V.
So let me just make a proposal and we can change it afterwards. And this is a must, I understood.
From my point of view, because it's not about that embedded, but it's about the instruction set should support this platform.
Shouldn't RISC-V be included in the must, given it's becoming more and more popular?
Okay, so it's not stalling, it's still rising, and then it's a must. Okay.
Yeah, I think so. I mean, we personally don't have any platforms yet, but we know that we will have in the upcoming years.
It's the very same with us. However, we were thinking about it also 3 years ago. It's still not.
Okay.
Okay. Yeah, I think in Europe, ARM is still convenient enough and not yet expensive enough to really consider a huge change towards RISC.
And RISC-V is not.
This is my perception. Yeah. Sorry.
Yeah, to kick.
Sorry?
And RISC-V is not performant enough to kick it out yet. Depending on the value and the costs that you have.
Yeah. So let's see. So maybe if ARM gets more expensive, then at some point. So I don't see the tipping point yet in Europe, but this is my personal opinion. So it's not based on anything, and I might be wrong there.
Same with me.
Okay, 7 minutes left. Just one thing, and correct me if I'm wrong, but I think on the MMU and MPU we made a decision already and said that MMU is not required and MPU is optional. So it's there, but it might not be activated. I think this is the decision we took so far. So this is what I would write down here in the document, and then I don't think it makes sense to open another topic today. Is my perception correct here, or?
From my point of view, yes.
Yeah, as I said, all of the devices that we support have MPU, so
yeah.
It's not
no, just because here it's still MMU and MPU combined, and I think we made a decision to look at these separated. So we say MPU, it's there, might not be used, but MMU, it's not necessary to have an MMU, because this is still, a lot of devices don't have an MMU. I think this is what we talked about.
Yeah. Well, our devices have MMU, so I don't really care, to be honest. But if, yeah.
Okay, so I will write this down. I will erase the pull request and later, and I will also share the meeting notes. I try to do it with Copilot, and let's see what comes out of it. Okay. Is there any other topic? We have 5 minutes left. Does anyone have another thing to share?
Just one thing about the RTOS. I think Sapphire and free RTOS are set from my point of view. Also, Linux RT, of course. I'm not sure about Expressive IDF. I'm not sure about ThreadX. Yeah, also in the Excel sheet, as Expressive IDF was not set, as far as I got. So the question is, what are your opinions on this? Natix,
So
I guess, Vidocura is highly dependent on it. So Vidocura is using Natix, as far as I know, because their WASI question kick in, at least. I think we don't have someone from Vidocura, am I right, on this call?
No, I don't think.
Okay.
Yeah.
Okay, just we do not have to extend it. Just wanted to raise this.
Yeah. So, yeah, maybe again have the separation in like first support, second support somehow, or focus and also. So again, I would. So if we focus on operating systems which have as mentioned before, which have a good abstraction towards the hardware, then we would make our own lives much easier, because we only need to provide, especially in the VASI field, provide solution against this API. So this would make it simpler for us, easier for us. And so I think again here we need to I think it was, I don't know who proposed it, to have like a subset then in the end. So looking at everything, so there's the landscape, and then we just pick out a couple of these. Yeah. So for me, it would be Sapphire and 3 others, but I think we had this discussion. We had a voting the last time, so we can factor the voting into the document. I think work on it. So I'm getting the vote. I will get the voting from the last meeting, and I will adjust the document according to it, and I will send out the pull request, I think today or tomorrow then.
Okay.
And so we're at the end of the time. Thanks for your participation, and I'm trying to figure out how to upload it. And see you all in 2 weeks then.
Yeah.
Bye.
Bye.